Alright, last lesson of the chapter. Just a reminder, your test is not going to be, if you're in 4th period, your test will be November 4th. If you're in 6th period, your test is also going to be November 4th. And if you're in my 7th period class, your test is going to be November 5th. So while this is the last section of the chapter, we still have some time to kind of tie up some loose ends. I hope you've been giving a full effort on all these, including the homework and checking your work and really trying to better yourself every day. So here we go. Example 1. I think you can try this one on your own. A, which side of triangle DEF is the hypotenuse? And B, what do you call the other two sides? So pause the video now and try this one out. Alright, what side of triangle DEF is the hypotenuse? Find the right angle. The right angle is at angle E. So you go across the triangle. The side opposite angle E is DF. That is your hypotenuse. The hypotenuse is always opposite the right angle. That is going to be the longest side. What do you call the other two sides? They're called legs. Legs. So DE is a leg, and EF is also a leg. We have a fourth postulate providing triangles are congruent. It's called the hypotenuse leg theorem, HL for short. So we got side, angle, side, 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 angle, side, angle, and now HL for hypotenuse leg. Hypotenuse legs are only going to be used in what type of triangles? Only in right triangles, because only right triangles have hypotenuses, right? So, here's an example. Triangle ABC, that's a right angle. Triangle DEF, triangle ABC, that is a right triangle, I should say. Triangle DEF, that is also a right triangle. We have a leg AB congruent to a leg DE. We have a leg AC congruent to a leg DF. These two triangles are congruent by the hypotenuse leg theorem. So this only works in right triangles. Okay, so this is an example of hypotenuse leg. Now, not all right triangles that are congruent are going to use hypotenuse leg. So here's an example. PQ congruent to GH, QR congruent to HK. We have a right angle at Q, a right angle at H. So the right angles are congruent. So a lot of students look at right triangles and they say, oh, these two right triangles are congruent. It must be hypotenuse leg. What's the problem with that here? The H stands for hypotenuse, right? What do we know about the hypotenuse at PR? Nothing. What do we know about the hypotenuse at GK? Nothing. So we cannot use hypotenuse leg here. This would be side angle side. Side angle side here. Alright, let's move on to a proof. I think you can probably do this on your own. So pause the video now. Give this one a try. Example 2. Alright. Let's first take a look at the given information. Given that angle U is a right angle. Alright, so we've got angle U right here. That's a right angle. Also, angle T is a right angle. Angle T is a right angle. Also, we are told that UG, here is UG, is congruent to TA. There is TA. So we have a right triangle. By the way, we're trying to show that triangle UGA is congruent to triangle TAG. Triangle UGA, that is a right triangle. We have a right angle at vertex U, so that is a right triangle. Same thing for triangle TAG. We have a right angle at T, so triangle TAG, that is also a right triangle. So we have two right triangles, which means hypotenuse leg might be used. Doesn't have to be, but it might be. UG, is that a leg or the hypotenuse? It's a leg. TA, is that a leg or the hypotenuse? It's a leg. What is the hypotenuse of triangle UGA? It's GA. What's the hypotenuse of triangle TAG? It is GA. So GA is congruent to GA by the reflexive property. So we're going to use the reflexive property here to show that the hypotenuses, hypoteni, are congruent. So here we go. First off, the given information. Alright, angle U is a right angle, that is given. Angle T is a right angle, that is also given. Let's continue with the given information. UG is congruent to TA. There you go. Now this next part you don't have to do. I'm going to do it in blue so you know you don't have to do it, but that is a leg. Alright, that's a leg. Let's continue on. We said that GA is congruent to itself. GA is the hypotenuse for both of these. So GA is congruent to GA. How do we know that? That is the reflexive property. Whenever we have a side congruent to itself, that is the reflexive property. Now, these are overlapping triangles, meaning they share a side in GA, and it's kind of one on top of the other a bit. So this is one of those examples where you may want to uncouple the triangles by tracing UGA and tracing TAG and then uncoupling them. You don't have to do that at this point. You might have figured out what's going on with this, and maybe your brain's able to see it a little bit better than it was before. GA and GA, that's the hypotenuse for both of those triangles. And now we know these two triangles are congruent. So let's get that going here. Triangle UGA is congruent to triangle TAG. And we know that because of the hypotenuse leg congruency postulate. Alright, there you go. That was example 2. Alright, example 3. If you want to try this on your own, let me give you a hint on this one. This is a problem where you need to draw in some construction lines, meaning you need to draw something on the figure that is currently not there in order to make a connection. So with that in mind, why don't you try example 3 on your own, and then once you need some assistance, unpause the video. Alright, so let's start with the given information. We have circle C. That tells us that C is the center of that circle. So that's given to us. Okay. Now, I see that CA is perpendicular to BR. So what that means is I'm going to have a right angle right here. I can create two right triangles if I draw in CB and I draw in CR. So CB is a radius, CR is a radius. All radii of the same circle are congruent. So we know CB must be congruent to CR. Alright, and to go along with that, CA is congruent to itself. That's the reflexive property. So this triangle on the left, triangle CAB, and this triangle on the right, triangle CAR, they must be congruent. Why does that come in handy? Well, we're trying to show that A is the midpoint of BR. So BA must be congruent to AR. Corresponding parts of congruent triangles are congruent. So BA is going to be congruent to AR, which means A is the midpoint of BR. So let's next say draw CB and CR. And the reason for that, see if you remember, it's construction lines. Construction lines. We're allowed to draw in segments like this if it helps us work the proof. Number 3. Alright, let's say, I'm going to stick with what we did in the construction lines there. I'm going to say CB, and the order in which you do this can be mixed up for sure. CB is congruent to CR. And the reason we know that, all radii of the same circle are congruent. Okay, now I know that I'm going to have a right angle here. I haven't gotten there quite yet, but we're going to have two right triangles. We're going to have two right triangles. So CB and CR, would you classify those as legs or hypotenuses? That's the hypotenuse, right? So I'm going to put HYP for hypotenuse. I'm kind of cheating a little bit because I know that's going to be the hypotenuse. Let's next say CA is perpendicular to BR. I knew that because it was given. 4 was given. Okay. And let's see here. What does it mean for those to be perpendicular? Well, it means that angle CA, actually, let me see here. It means we have a perpendicular, well, if it's perpendicular, it means we have a right angle, which means CAB and CAR. So let's change this up a little bit. Let's say triangle CAB. I'll let you jump to this. And triangle CAR are right triangles. Okay? Triangle CAB and triangle CAR, they are right triangles. You could do that. You could say angle CAB and angle CAR are right angles, something like that. Yeah. So how did I know they are? That CAB and CAR are right triangles? You know, as I'm thinking about this reason I'm going to put here, I'm going to say definition of perpendicular. But what's the definition of perpendicular? The definition of perpendicular is that uh, when two line segments or two lines are perpendicular to each other, they form a right angle. So I think it's actually better to change this from triangle CAB and triangle CAR to angle CAB and angle CAR are right angles, okay? Are right angles. That's a better definition of perpendicular. Now, I'm not going to require you to state that they are right triangles. We're going to say that that's like assumed, I guess. If you have two triangles and one of the angles is a right angle, then that's a right triangle. I'm not going to make you explicitly state that. So just state you have a right angle. Sorry for that little change of mind there on that number 5. Number 6. So now we have two right triangles, right? We have triangle CAB. We've identified that we have a right angle at angle CAB. We have triangle CAR. We've identified we have a right angle at CAR. We have hypotenuse in CB congruent to a hypotenuse in CR. What do you think we need to do next? We need to identify CA is congruent to CA. CA is congruent to CA. How do we know that? That's the reflexive property. Number 7. What do we now know? We now know that triangle CAB is congruent to triangle CAR. And how do I know that? Hypotenuse leg. Congruency postulate. So let's pause for a second. Let's think about what it is we're trying to prove. We're trying to prove that A is the midpoint of BR. Well, if A is the midpoint of BR, that means BA is congruent to AR. And we now know that's true because these two triangles are congruent. So we're going to say BA is congruent to RA, or any other combination. Now you could have said AB is congruent to RA, or BA is congruent to AR, whatever. And we know that because corresponding parts of congruent triangles are congruent, CPCTC. And now number 9, A is the midpoint of BR. And that is going to be definition of midpoint. All right. So there you go. There is that 9-step proof there. On to example 4. Given we have circle A, so remember that means A is the center of that circle. AM is the altitude of triangle SAP. AM is the median of triangle SAP is what we're trying to prove, okay? So pause the video now, try this one on your own. I think you can probably do it. All right, well, if we have circle A, I know AS is congruent to AP because all radii of the same circle are congruent. I also notice that we have AM congruent to AM. That is a reflexive property. I also notice that we are told that AM is an altitude of triangle SAP, which means we have a right angle right here at angle AMS and a right angle at angle AMP. So we have two right angles. The hypotenuse is congruent to the hypotenuse. That'd be the two radii. And then a leg is congruent to a leg. That'd be AM congruent to AM. And what are we trying to show or prove? We're trying to prove that M is the median of triangle SAP. What does it mean for it to be a median? Well, the median travels from the vertex to the midpoint of the opposite side. From the vertex, A, to the midpoint. So we're trying to prove M is the midpoint. That's what we're trying to do. If M is the midpoint, then SM is congruent to MP. So let's get going. First, the given information. We have circle A, that is given. Let's build off of that. Building off of that is going to be the two radii are congruent. That would be AS and AP. So segment AS is congruent to segment AP. These are going to be the hypotenuse, by the way. HYP, you don't have to do this. How do we know that AS is congruent to AP? All radii of the same circle are congruent. There you go. All radii of the same circle are congruent. Let's go back to the given information. AM is the altitude of triangle SAP. All right, there you see that. AM is the altitude of triangle SAP. And again, that is given to us. Number 4. What does it mean for AM to be the altitude of triangle SAP? Well, it means we have a right angle here. We have a perpendicular intersection between AM and SP. So we're going to say that angle AMS and angle AMP are right angles. And that's going to be the definition of altitude. So angle AMS and angle AMP are right angles. That's the definition of altitude. Now, I'm not going to require you to state that these two angles are congruent and then say all right angles are congruent. In hypotenuse leg, all we have to do is establish that we have a right triangle. And by saying we have right angles at AMS and AMP, that is enough to establish right triangles. So that's good enough for me. This is different from side angle side. Think about side angle side. The letter A shows up in side angle side. So you have to explicitly state you have a pair of angles that are congruent. Think about angle side angle. In angle side angle, we have two pairs of angles that are congruent. So again, you have to explicitly state that those two pairs of angles are congruent to each other. So you do need to do that in those other problems, but in hypotenuse leg, it's kind of a special case. You just have to establish you have a right triangle, and we've done that there with number 4. Number 5, we got to have those legs congruent to each other. That's AM congruent to AM. That's the reflexive property. There you go, you see that. AM congruent to AM, reflexive property. All right, now, remember, we're trying to show that AM is a median of SP, which means we need to show that SM is congruent to MP. So the way we're going to do that is we're going to show these two triangles are congruent. So statement number 6, triangle AMS is congruent to triangle AMP. Please always check your congruency statements. A is where the one tick mark side meets the shared side in the triangle on the left. It's where the one tick mark side meets the shared side in the triangle on the right. To get to M in the triangle on the left, we travel down the shared side. In the triangle on the right, to go from A to M, we travel down the shared side. So M corresponds to M. Both are traveling down the shared side, and therefore S must correspond to P. But what is S? S is where the one tick mark side meets the blank side. P is where the one tick mark side meets the blank side. So how do we know the triangle AMS is congruent to triangle AMP? That is the hypotenuse leg congruency postulate. There you see that hypotenuse leg congruency postulate. On to number 7. Let's see. SM must be congruent to MP, so SM has to be congruent to MP. So SM, that is third and second. MP, or we can say PM, that is third and second. Either way would be acceptable. That is, corresponding parts of congruent triangles are congruent. Okay. And finally, number 8, AM is a median of triangle SAP, and we know that because of the definition of a median. The median is the segment that connects a vertex to the midpoint of the opposite side. So if we have just shown that SM is congruent to PM, that is good enough for me. All right, great. Congratulations. That's it for section 3.8 and chapter 3. Please continue on with the 3.8 homework. Be sure to check all those homework videos I've created to get that extra push and help that you might need. Appreciate your attention. Good luck, everybody.